Hello guys, I hope you must have noticed in the last part that we were not solving questions just on the concepts of trigonometric equations. It involved questions and concepts based on a whole lot wider concepts. So I'll be continuing with those concepts and those types of questions based on the competitive level questions in this part also. Let's start with that. So moving on to the next part, the example that we have is x plus y is equal to 2 pi by 3 and sin x over sin y is equal to 2. It's an MCQ question, that is, it can have more than one correct answers. It's from JEE. Let's start with the first equation. In this first let me explain you what do we have to do. We are given two equations and we have to find the value of x and y lying in the interval 0 and 4 pi, and we have to find the number of values that would be lying in this region that would be satisfying both the equations simultaneously. If I start with the first equation, I have x plus y is equal to 2 pi by 3. I would have y is equal to 2 pi over 3 minus x. This can be put in the second equation, which can be rewritten as sin x is equal to 2 sin y. I am replacing the value of y in the second equation from the first. That is, y is equal to 2 pi by 3 minus x. On the left hand side it is, so the equation would become sin x is equal to 2 sin of 2 pi by 3 minus x. Now sin of 2 pi by 3 minus x is of the form sin a minus b, which can be written as sin a cos b minus cos a sin b. I do the same, keeping the left hand side intact. Sin x, I'll have 2 sin of 2 pi by 3 cos of x minus 2 cos of 2 pi by 3 sin of x. Sin of 2 pi by 3 is equal to sin of pi minus pi by 3. Pi minus pi by 3 lies in the second quadrant, in which sin is positive. So sin of pi minus pi by 3 is instead equal to sin of pi by 3, which is sin 60, which is root 3 by 2. When multiplied with 2, it gives me just root 3. So root 3 cos x minus, now minus 2 is multiplied with cos 2 pi by 3, which is cos of pi minus pi by 3, which is negative in second quadrant. So it will be minus cos 60. So minus 2 into minus cos 60 is minus 1 by 2. So minus 2 into minus 1 by 2 is plus 1 again, and I get positive sin x on the right hand side as well. So these cancel out, and that gives me root 3 cos x is equal to 0, or cos x is equal to 0. So that's the final equation that I get, to which the solution is x is equal to 2n plus 1 pi by 2, that is odd multiples of pi by 2. Now if I plot this in the region first 0 to 2 pi, the solutions I would get is 2, that is pi by 2, and 3 pi by 2. You know that. So these would be the two solutions in the first circle. If I start for discussing in the second circle, the two values would be again at pi by 2 and 3 pi by 2, just with the phase difference of 2 pi. So the values that would be here, that I would be getting in the region 0 to 4 pi would be 4, that lie in the region 0 to 4 pi and satisfy the two equations at once. So only 4 values would lie. Now let's check for the value of y. For checking for the value of y, I would be putting in the solution, that is 2 pi by 3 minus x. X was equal to 2n plus 1 pi by 2, so I would just write that 2n plus 1 pi by 2, which gives me 2 pi by 3 minus pi by 2 minus n pi, which again is equal to pi by 6 minus n pi. So y would be, if I put n is equal to 0, I get pi by 6. If I put n is equal to 1, I get a negative value which is before 0, so it would be lying outside the region. So I would start with the negative values then. If I have n is equal to minus 1, so that will be pi by 6 plus pi, or 7 pi by 6. For minus 2 it will be 13 pi by 6, and for minus 4 it will be, for minus 3 it will be minus 19 pi by 6. If I put n is equal to minus 4, that will be pi by 6 plus 4 pi. So it will be beyond more than 4 pi, that will be pi by 6 plus 4 pi, so it's an addition to the angle 4 pi and we're lying outside the region, so it will also be having 4 solutions. So n of y lying in the region 0 to 4 pi is 4, and hence the options that would be marked in this answer would be D, that is y in the region of 4 and x in the region of 4 again, so it will be A and D. Moving to the next part, I am again given two equations. It's an IIT-JEE question. So the number of values of theta in the interval minus pi by 2 to pi by 2 such that theta is not equal to n pi by 5 for n having integral values, and the equations that are given to me are tan theta is equal to cot 5 theta and sin 2 theta is equal to cos 4 theta. So I'll write the first equation as tan theta is equal to tan of pi by 2 minus 5 theta, cot theta being rewritten as tan of pi by 2 minus 5 theta. This is of the form tan theta is equal to tan alpha, to which the general solution is theta is equal to n pi plus alpha. Here alpha is pi by 2 minus 5 theta. So the equation I get is 6 theta is equal to n pi plus pi by 2, pi by 2 taken common, so I get 2n plus 1 is equal to 6 theta. So theta is equal to pi by 12, 2n plus 1. Now in the region 0 minus pi by 2 and pi by 2, I will check how many values lie. For the value of n equal to 0, I get pi by 12. For the value of n is equal to 1, I get 2 plus 1, that is 3 pi by 12 or pi by 4. For n is equal to 2, I get 4 plus 1, that is 5 pi by 12. If I put n is equal to 3, I get 6 plus 1, that is 7 pi by 12. Now 7 pi by 12 is lying beyond pi by 2, so I'll neglect that. I'll start with the negative values now. If n is equal to minus 1, I will have minus 2 plus 1 in the bracket, that is minus pi by 12. If I put n is equal to minus 2, I would have minus 4 plus 1, that is minus 3 pi by 12, or minus pi by 4. If I put n is equal to minus 3, I get minus 6 plus 1, that is minus 5 pi by 12. If I put n is equal to minus 4, I'll have minus 8 plus 1, that is minus 7 pi by 12, which again would be lying before minus pi by 2, hence would be neglected, and these are the 6 values which satisfy tan theta is equal to cot 5 theta and lie in the interval minus pi by 2 to pi by 2. Checking for the second equation, I have sin 2 theta is equal to cos of 4 theta. So sin 2 theta can be written as sin cos of pi by 2 minus 2 theta is equal to cos of 4 theta. This is of the form of cos theta is equal to cos alpha, to which the general solution is theta is equal to 2n pi plus minus pi alpha. So here theta is pi by 2 minus 2 theta is equal to 2n pi plus minus 4 theta. I am rewriting it as just rearranging the terms, separating the theta values on one side only. Now I will have to solve for the two values. One would be belonging to the positive sign on the right hand side and the other one would be belonging to the negative side on the right hand side. I will proceed to the next slide with the same equation, that is pi by 2 minus 2n pi is equal to 2 theta plus minus 4 theta. So I will consider the positive sign here, which would give me pi by 2 minus 2n pi is equal to 6 theta, and theta would be equal to pi by 12 of 1 minus 4n. So theta would be giving me values. If I put various values of n here, if n is equal to 0, I would get pi by 12. If I put n is equal to 1, I would get 1 minus 4, that is minus 3 pi by 12, that is minus pi by 4. If I put n is equal to 2, I would get 1 minus 8, so that would again be a negative value, that is minus 7 pi by 12, which would be before minus pi by 2. I would start with negative values then, that is if I put n is equal to minus 1, I would have 1 plus 4, that is 5 pi by 12, positive 5 pi by 12. Then if I put n is equal to minus 2, I would get 1 plus 8, which would be lying beyond pi by 2. So these are the three values for the positive sign. Considering the negative sign now, I have pi by 2 minus 2n pi is equal to minus 2 theta, which would give me 2 theta equal to 2n pi minus pi by 2. Theta is equal to pi by 2 taken common and 2 transposed cross multiplied in the denominator to give me pi by 4. I would have 4n minus 1. So theta would be, for n is equal to 0, the 2 taken common. Yep. So for n is equal to 0, I would have pi by 4. I put n pi by 2 taken common from this and put into this. That gives me 4n minus 1. Very good. So that gives me pi by 4. If I put n is equal to 1, I get 3 pi by 4, which would be lying outside the region. If I have theta n is equal to minus 1, I would have minus 5 pi by 4, which would be again lying outside the region. So only this value would be here. Now, so I have 4 values, 1, 2, 3 and 4. So for these 4 values, the equation sin 2 theta equal to cos 4 theta, lying between minus pi by 2 to pi by 2. These are the 4 values. That is pi by 12 plus minus pi by 4 and 5 pi by 12. For the equation tan theta is equal to cot 5 theta, we had theta was plus minus pi by 12 plus minus pi by 4 and plus minus 5 pi by 12. Hence this would be the only solution that is coinciding with this more general, more variant, more wider solution. So the earlier solutions that we have is, this would be the more general solution to the equation. So guys, in this part we learned that we have to find the solution of the trigonometric equation in a particular period or an interval. So that was dealt in the 2 parts, that the 2 questions that we had in this part. I'll be continuing with the competitive level questions in the next part also, so stay tuned.